There are 4 analytical questions are there in part C, module 1. So, 7th question, why does a steel pipe in a large copper tank corrodes and causing rapid destruction? So, this is reasoning question. You have to write the reason. Why does a steel pipe in a large copper tank corrodes and causing rapid destruction? What you will write for this answer? Hello? A steel pipe is fitted in large copper tank. Hello? Hello, students? Hello?
Yes, ma'am.
Small steel pipe we are fitting in a large copper tank. Small steel pipe, it will undergo corrosion. Why? Causing rapid destruction. Why? Hello? So when we have here anodic areas wise, if there is a small anodic area and large cathodic area, what happens, ma? Students? Hello? If there is a small anodic area and large cathodic area, okay? What is the reaction? Hello? Hello, students? Hello? Hello? What these 42 members, what you are doing?
Oxidation.
Huh?
Absorption of oxygen, corrosion, ma'am, basically.
Where the corrosion takes place, there is a small steel pipe fitting in a large copper tank. Steel pipe is undergoing
Corrosion.
corrosion. Steel pipe is undergoing corrosion. It will act as it becomes small anode. Okay, there is a large copper tank is there. Because there is a large area of cathode, so it will undergo reduction reaction. Since there is a large cathodic area, it will it wants more electrons, it will gain electrons, so that here the oxidation reaction at a small anode, okay, it will be increasing. Okay, so more and more oxidation takes place at a small anodic area. Okay, so it will undergo severe corrosion. Okay, it will undergo rapid destruction of the metal steel pipe. So you have to write the reason. 7th question. So I have sent you for part C also. I have given you answers. Okay, na? So you write, you see the answers and learn perfectly so that you can write when you get in the exam. So next, students, you have to give me the answer, ma. Just joining the class is not enough. Everybody on your video. Everybody on your video. Hello, students. Hello, students on your video. Tell me the answers. Okay, na? Roll number 1, 3, 9. What you are doing? 9, 52, 54, 64, 20, 22. Any are there? 60, 65. Tell me the answers. Now, 8th question. How is cathodic protection of iron is different? That is different from its galvanization. How it is different? Tell me. How is cathodic protection is different from its galvanization?
Cathodic protection is when we connect it to a more active metal and then it stops the corrosion. Whereas galvanization, the zinc, we actually cover it with zinc or some metal so that we cover it with a sacrificial metal so that it protects the base metal.
Okay, so we are giving a coating in galvanization. We are giving anodic coating or cathodic coating on the surface of the base metals. Where are the others, ma? Why you are not? Why you are? Okay, on your video, everybody. Hello, students. Others. Hello. Now next, ninth question is galvanized container is not used for storage of food products, but tin coated container is used. Comment on the statement. What you will write the reason for this? Galvanized container is not used for storage of food products.
Ma'am, galvanized container actually has it's not that resistant to heat, and so it's not used.
No, not resistant heat. Galvanized container means we are giving zinc coating on iron.
For normally when this food had dissolves acid or something, so due to the zinc will get dissolved into the acid and it will make the food harmful or
Zinc is actually zinc is toxic in nature. Zinc is toxic in nature. So when we use this galvanized containers for storage of food products, it forms poisonous compounds. Okay, that is dangerous. Okay, na? So zinc is toxic in nature. So we should not use galvanized containers for cooking or storage of food products. So but tin coated containers are used. Why?
Ma'am, tin is non-toxic in nature.
Tin is non-toxic in nature, so we can use for tinned utensils. Tinned utensils we can use for cooking or any we can go for packing food or storage of the food products. So ninth question, you read carefully and you have to write my answer if you get for CIE1 exam. Now 10th question, iron does not rust if the zinc coating is broken in a galvanized iron pipe, but rusting occurs much faster if the tin coating over iron is broken. What you will write reason? Students.
Zinc is more electropositive than iron.
Then what happens if any?
So ma'am, zinc will act as anode and iron will act as cathode here.
Okay, if zinc coating is broken also, it will act as anode and iron will act as cathode. Next, tin. About tin coating, you tell me.
Tin is less positive, so the tin coating, if it is broken, then iron will act as anode and get oxidized.
Okay. So you write my answers carefully. Okay, if you get these reasoning questions in the exam. Okay, na? 4 questions are there, reasoning questions, and 6 problems are there. Okay, in part C. Now tell me, students, if you read these 10 questions, how many you will get in the exam? Hello? 2 you will get.
One or two.
Not 1. How many you will get? See, from module 1 you will get 2 questions, ma. 1AB, 2AB. So 1A is you will get theoretical. 1B is a problem or reasoning question. 2A is a theoretical. 2B is problem or reasoning question. Now tell me how many questions you will get from this 10?
2, ma'am.
2 you will get. For how many marks you will get?
3 marks each.
Each one 3 marks. Each question 3 marks. Understood, ma? Okay, you have to prepare these 10 questions thoroughly so that you can write 2 questions. Okay, na? So this is question bank model 1 questions, ma. So part B 20 are there. Okay, so you can read from handwritten notes. Part B. Part C, problems are there in your classwork, and reasoning questions I gave separately. Prepare well. Okay, na? We'll go for second module, ma. Question bank. Now, students, question bank. This I will send you. Okay, na? Question bank module to water technology. So in this also part A, part B, part C. Part A short answer questions. Part B long answer questions. Part C problem solving and critical thinking questions. Now part A. Students, what is hardness of water? What is hardness of water? Hello. Ma, what is hardness of water?
Water, the characteristic of water which prevents lathering of soap.
Prevents the lathering with the soap, which prevents lathering of the soap. So that only you have to write, just to define hardness of water. Okay, it is the characteristics of water which prevents the lathering of soap. Now compare temporary and permanent hardness of water. Tell me what is temporary, what is permanent.
Temporary is when it's when the calcium bicarbonate and magnesium bicarbonate salts will get temporary hardness.
Temporary hardness.
Whereas calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate will get permanent hardness, ma'am.
Permanent hardness.
Temporary hardness can be removed to physical methods, whereas permanent hardness we need to use chemicals, ma'am.
Chemical, okay. Now students, what is the basic principle? Asked only principle, ma. Basic principle involved in estimation of hardness of water by EDTA method. So what is the principle? So what is forming when you are using chemicals like EDTA in hard water? So what is the reaction taking place? What is forming? Principle, you tell me. Students, this is the principle. You will take hard water. You want to remove this calcium and magnesium present in water by using chemical EDTA. Now tell me, what is the principle? So first we will take hard water. We will add EBT. So what is forming in water? Hello.
Violet color complex.
Violet color complex is formed. Okay, that is formation of calcium EBT and magnesium EBT complex. If calcium and magnesium present in water only, you will get this color, violet color. Otherwise, which color you will get, ma? Blue color. Blue color you will get because EBT is a blue color indicator. EBT is a blue colored indicator. So if calcium and magnesium present, then we get a complex calcium EBT or magnesium EBT complex. So that the color we will get is a violet color. So what you are doing, my next step?
Yeah, we add EDTA.
We add EDTA to the colored solution, violet colored solution. We are adding EDTA. So the EDTA, it reacts with the calcium EBT and magnesium EBT complex and forming calcium EDTA or magnesium EDTA. What is that complex, ma? It is
colorless stable complex.
Colorless stable complex. It is colorless stable complex is formed, releasing free EBT indicator, that is blue color. So at the end point, we get color changing from wine red color to blue color. Wine red color to blue color. So this is the principle, ma. You have to write this. Okay. So next question. Students, define ppm. Units, 4 units are there, ma. 1 ppm is equal to, take out your classwork. 1 ppm is equal to, hello students, ever lera, asalunara lera. 48 students are there out of 65. Hello? What you are doing in the morning? Sleeping or what? Hello students, you are sleeping?
Yes, ma'am. No, ma'am.
Yes, students, A section students sleeping, I think. Only 48 are there. Or having breakfast or you went some outside. 48 are there out of 65. And I am discussing question bank. Again, I won't discuss. Hello students, tell me what is ppm? 1 ppm
one part
equal to?
ppm is equal
10
to
per 6 parts of units. 1 by 10 per 6 parts of units.
1 ppm is equal to 1 part na complete ga cheppalama. 1 ppm
One
is
part
equal to
one
part
part
of
CaCO3
CaCO3 equivalent hardness
by 10 per 6 parts of
10
units.
per 6 parts of water. 10 per 6 parts of water I have given in this PPT. You can follow. Okay, na? I think I have given. See, 1 ppm is equal to 1 part of calcium carbonate equivalent hardness for 10 per 6 parts of water. Here 6 I didn't take. Okay, I didn't given. I have not given 6. 10 per 6 parts of water. Now tell me milligram per liter. Hello students. Milligram per liter. 1 milligram per liter is equal to
1 milligram of
Impossible.
CaCO
1 milligram of calcium carbonate
per 10 per 10 per 6
10 power 6
milligram per liter of water.
10 power 6 milligram of water. 10 power 6 milligram of water. 1 milligram per liter is equal to 1 milligram per
milligram
liter is equal to 1 milligram of calcium carbonate equivalent hardness per 10 power 6 milligram of water. So we have to write 10 power 6, 10 power 6 milligram of water. So this you remember, this line is enough. 1 milligram per liter is equal to 1 milligram of calcium carbonate equivalent hardness per 10 power 6 milligram of water or per liter of water. Okay, na? So why I am telling to write 10 power 6 milligram of water means so that you can understand here 1 milligram per liter is equal to 1 ppm. Now tell me students, degree clerk. What is degree clerk? Tell me.
1 part of CaCO3 equivalent of hardness causing salt per 70,000.
Enta? How much, ma? How much?
70,000.
70,000 parts of water. Okay, very good. Now tell me French, degree French, tell me. Degree French, tell me.
1 part of CaCO3 per 10 per 5 parts of
10
water.
per 5 parts of water.
Water.
Completed. 4 and 5 question completed, ma. Now what are the disadvantages of hard water, ma? Domestic wise, tell me. Any 2 points you tell me, students? Domestic wise.
Boilers.
Boilers, tell me, boilers, what happens?
It forms precipitates due to hard water and
It forms precipitate. We get in boilers precipitate. What else?
in textile industry the hard water would actually change, dyes would get uneven.
Okay, so we won't get exact shades of the colors, yes sir, no? So I have given here, ma, just to follow this domestic purpose. If we use hard water, we get here the precipitate in the like a layer, white layer we will get in the utensils, and we have to supply, we have to use more fuel, and time also it is required, more time is required for cooking. Okay, so drinking also it is very dangerous to drink hard water. It affects our health only. Okay, so we get stones in the kidneys, or any problems will be there in urinary tract. Okay, and we get throat infection. Okay, so we have to drink mineral water. We should not take hard water. Okay, so bathing also we get the problems, ma. Okay, when we get a sticky precipitate. So this is domestic. Industrial purpose, we discussed that textile industry we have to use only soft water, otherwise we get we are not getting exact shades of the colors if water is containing calcium and magnesium salts. Okay, sugar industry also we should not use hard water containing sulfates, nitrates, because if we are using, we won't get crystallization of sugar. Okay, so it will be decomposing. So we have to use only soft water in sugar industry. In boilers also we have to use only soft water. Okay, we get boiler corrosion. Okay, in pharmaceutical industry we have to use only soft water. In preparation of cosmetics, tablets, injections, we have to use only soft water. Okay, so write some points more. Now next, what is soft water, what is hard water? Students, tell me. Hello.
Soft water doesn't have any salts, where the hard water does have all those hardness causing salts.
So soft water means there is no dissolved salts present. Hard water means presence of dissolved salts. Then how do you know that water is soft water or hard water?
To lathering of soap or
If the water gives
lathers with soap is soft water.
soft water. If the water
Doesn't lather with soap is hard
doesn't
water.
lather with soap, it is hard water. Okay. Girls, you are not there, huh? They went. Hello. Hello.
Yes, ma'am.
Unnara?
Yes, ma'am.
What is soft water? Give the examples of any two soft water resources.
River.
River, river soft water,
Rain.
impurities will be there, ma, in river. In river, impurities will be there. Rainwater, hello.
Yes. No impurities, ma'am.
No impurities. Okay. Now, how permanent hardness is removed, ma? Students, how permanent hardness is removed from hard water? Tell me.
Change.
Process.
By the process of lime soda process. Inka?
Ion
Exchange process. Okay. So right, ma. Okay, we can remove permanent hardness from hard water. Okay, by ion exchange process. Now tell me 10th question answer. List the salts responsible for the temporary and permanent hardness of water. Now tell me the list.
Calcium bicarbonate, magnesium bicarbonate, they are temporary salts, ma'am. And calcium chloride, magnesium chloride, calcium sulfate, and magnesium sulfate. These salts are permanent salts.
Permanent salts. Okay. Now 10th question is that, ma. Next. So I gave here types of hardness. Okay, na, in PPT. Ion exchange method also I gave example. So compare soft water, hard water. Now, students, what is meant by treatment of water? Treatment of water. Treatment of water we will do, ma. Yes or no? Students, you are doing ion
Yes, ma'am.
exchange, reverse osmosis, potable water. Tell me, treatment of water ante enti? What is meant by
removing hardness.
removing?
Removing salts from water.
Removing salts from the water. Two ways are there. How you will remove?
Physical,
Internal and
chemical.
external.
Internal and
External.
Very good. Okay. So internal means we will get like a complex formation. Okay. Or we can convert hard salt into soft salts. We can remove it. External means we are removing this dissolved salts by using chemicals. Now students, tell me, what is softening of water? Hello. What is softening of water? Not hardness of water. What is softening of water? Same answer only, previous answer only. Hello.
To remove hardness causing salts in water.
To remove the hardness causing salts present in water, that process is called softening of water. Now, how is natural water sterilized? By bleaching powder? Tell me. How you will go for sterilization? By using bleaching powder. We will use calcium oxychloride in water. Tell me. When you add bleaching powder, what happens, ma?
Ma'am, it breaks down into HO.
Now tell me. Tell me, when you are adding bleaching powder, calcium oxychloride in water, what happens? What you are getting? What you are getting?
Calcium hydroxide.
Calcium
chlorine.
You are getting chlorine. So chlorine in presence of water, what we are getting?
HOCl.
HOCl. Okay, HOCl, that is hypochlorous acid. Hypochlorous acid. So this will kill the germs present in the water. So this you have to write. Okay, na? Hello. Students,
Yes,
this you have to write. Okay. So next one. Next is explain the breakpoint chlorination in treatment of potable water. Breakpoint chlorination, students. Okay, so this one. So when we add 1 gram of chlorine, when we are adding 1 gram of chlorine, it will oxidize all reducing impurities present in water, like iron, manganese. When we are adding 2 grams of chlorine, the chlorine, it will react with ammonia, forming a chloramines. When we are adding 3 grams of chlorine, so it will produce hypochlorous acid, and it will destroy all the bacteria present in water. When you are adding 4 grams of chlorine, so it is called residual chlorine. It is excess chlorine present in water. So no need excess chlorine here because we get a bad taste and odor. Okay. So this you have to write more breakpoint chlorination. Hello, students. Hello, listening to me?
Yes, ma'am.
Hello. Okay. So you read the notes so that you can write well. Okay, breakpoint chlorination. So by breakpoint chlorination, we come to know that how much exact amount of chlorine we can add in water to destroy bacteria completely. We can destroy bacteria present in water. Now, explain the reverse osmosis process to produce potable water. So you have to explain the method. Okay, now so we are taking here one chamber. We are arranging semi-permeable membrane. Okay, in the middle of the chamber we are arranging semi-permeable membrane. Top of the chamber we will take seawater. Below we will take pure water. So we will apply the pressure, extra pressure on the high concentrated side. Contaminated water, what we are taking seawater, we apply more pressure on that side, okay, concentrated side solution, so that the flow of solvent, the flow of water molecule from contaminated water, it flows, okay, through the semi-permeable membrane to the lower chamber. So we can collect pure water, we can use that water. So explain the method with the diagram, draw the diagram, learn the diagram. Okay, you have to draw the diagram, you have to explain the method. Okay, na? Students are listening to me? Hello?
Yes, ma'am.
Okay, na? Okay. Now, what is screening, ma? What is screening? Students, what is screening, ma? Hello?
Removing large
Through the
Removing
floating matter.
floating matter. Removing floating matter present in water. What is floating matter? Example.
Leaves.
Leaves, any paper or any plastic. Okay, so you can remove. Screening. Okay, what is screening means, right? What are the advantages, ma? Reverse osmosis. Students, what are the advantages? I think I didn't give. Students, what are the advantages, ma? Hello? Okay, I have not given, no problem. So what are the advantages, ma? First advantage, tell me. Hello? We can remove. We can remove. What we can remove?
All the salts complete.
Semi-permeable membrane, it is allowing only solvent, not solute particles. Now tell me first point. We can remove. We can remove the dissolved salts present in water. We can remove ionic and non-ionic salts present in the water. So first you write that point, ma. Second point, we can remove colloidal particles present in water, that like silica oxide. Okay. So next, this water we can use for ion exchange process, for water purification. Hello, students listening to me? Hello?
Yes, ma'am.
Fourth point, semi-permeable membrane we can use up to 2 years. Means once you are fitting the plant, okay, once you are buying the semi-permeable membrane, okay, after fitting in the chamber, you can go for purification of water for up to 2 years. You can purify the water. Okay, after 2 years, you can remove that semi-permeable membrane. You can replace with the fresh one. Okay, so these are the advantages, ma. You have to write for reverse osmosis. Now, students, what are the advantages and disadvantages of ion exchange process? Advantages. Tell me 2 points. Hello?
The hardness of water is below 2 ppm.
Hardness of water is 0 to 2 ppm. Okay, 1 point. Second point. Hello, students. What is the second point, ma? We can use this water in
Boilers and
boilers. We can use this water in boilers. Now tell me disadvantages.
it's costly.
Expensive.
Cost, okay, costly process. We have to buy the chemicals. We have to buy this ion exchange resins. Okay, and there should not be more turbidity in water. We have to see that the turbidity or clay particle or mud, it should below 10 ppm. Okay, so you can write that points. Now, students, what is sedimentation, ma? Students, what is sedimentation? Hello.
To remove
suspended particles. What you will do for that? What you are doing? Sedimentation process.
we allow the water to stand undisturbed in a tank.
For
So
some
the
time.
suspended particles will settle down due to gravity, which can be again.
Okay, we can remove clear water, okay, with pumps, and we will take out that impurities from the tank. Okay, na? Now next one. What is potable water, students? Hello.
Which is safe to drink.
Safe to drink. So water which is safe for human consumption. Okay, so that is called potable water without any contaminants. Okay, water without any contaminants, and it should be safe for human consumption. Okay, so 20 questions, short answer questions is completed, ma. But you concentrate more on part B, part C, so that you can write part A answers also. But you read each question. You should be able to write part B and part C. Now, first question, part B, long answer questions. Why do we express hardness of water in terms of calcium carbonate equivalent? Why do we express hardness of water in terms of calcium carbonate equivalent? So why we are expressing the hardness of water? Tell me, in terms of CaCO3.
Weight is 100, so easy to calculate.
Molecular weight is 100, easy to calculate. Okay. One more point is there. One more point is there.
It is an insoluble salt.
It is insoluble salt, most insoluble salt in water. Okay, next one. Why hard water fails to produce lather with soap solution? Why hard water?
Forms PPTs with Mg and calcium.
Okay, okay, you write that. Okay, so distinguish between hard water and soft water. Tell me. Distinguish between hard water and soft water. I gave already. Distinguish between hard water, soft water. Tell me, what is hard water? Hello, students. What is hard water? Tell me first. Hello?
Contains dissolved magnesium, calcium.
Hard water contains dissolved calcium and magnesium salts. Okay. Next, soft water. Next, soft water. Hello. Soft water, tell me. Soft water does not contain calcium and magnesium salt. Okay. So first point you can write water which does not produce lather with soap solution. Okay. And forms white precipitate or curd. White curd is called hard water. Water which lathers easily on shaking with the soap solution is called soft water. Now next. Now second question. Describe the experimental procedure for the determination of total hardness by EDTA method. So students, you explain EDTA method completely. Okay, na? Learn and explain completely EDTA method. Principle, procedure, everything you explain. Okay. So already we discussed, principle. Where is that? This principle you have to explain, and procedure 4 steps are there. What is the first step, ma? Hello? Hello, students. What is the first step? Hello? 4 steps are there, ma. What is the we will find the molarity of standard. We'll find molarity of standard hard water. Step 1. So tell me molarity formula. Molarity formula. Weight by
molecular weight into 1000 by V in ml.
By V in ml. Okay. So we'll find out step 1, molarity of standard hard water. Now step 2, you tell me. Step 2. Step 2. Hello. Hello, step 2.
Molarity of EDTA solution.
Molarity of EDTA. Formula you tell me. Formula you tell me.
M2 is equal to M1 V1 by V2.
M2 is equal to M1 V1 by V2. What is M1, ma? What is M1?
Molarity of standard water.
Molarity of standard water. What is M2?
Molarity of EDTA water.
Molarity of EDTA. What is V1?
Volume of standard water.
Volume of standard water. V2?
Volume of EDTA solution.
Volume of EDTA. Okay, ma. Step 3, you tell me. Step 3. What will find out step 3?
Temporary hardness.
Temporary hardness. Step
Molarity
3, ma. Step 3. Total hardness. Step 3, total hardness. Step 4, permanent hardness. Remember. Step 3, total hardness. What you will take in step 3, ma? You will take hard water or boiled water?
Hard water.
Hard water.
Hard water you will take. Okay, sample water you will take. Tap water you will take. Step 3. Tell me formula. Tell me formula.
M3V3 is equals to M2V2.
M3V3 is equal to M2V2 dash. Okay. M3 is
Molarity of hard water.
molarity of hard water. M3. Okay. So M4 not. V3
Volume of hard water.
volume of hard water. M2 molarity of EDTA you know already. V2 volume of EDTA. Okay. Consumed with the hard water. Okay, ma. Now step 4. Last step, tell me. Step 4. Which water you will take?
Boiled water.
Boiled water. Tell me formula.
M4V4 is equals to
M4V4 is equal to M2V2. Okay. So M4 is molarity of boiled water. We are going to find out. V4 volume of boiled water. M2 molarity of EDTA. V2 is volume of EDTA consumed. So M3 will find out total hardness, that is M3 into 100 into 1000 will convert into ppm. M4, that is M4 into the permanent hardness. So M4 into 100 into 1000 will convert into pp. Okay. So you have to write all the 4 steps. Okay. So explain properly. Now, what is hardness of water? Already we know. Okay, the water, its characteristics which prevents lathering with soap. Explain the terms temporary and permanent hardness. Okay, explain. Temporary and permanent hardness with examples. I have given here. You see, temporary hardness. Okay, na temporary hardness. Reactions you learn. Write permanent hardness. Reactions you learn. Give the examples. Okay, na. So completely you have to write because it is long answer question. Learn properly and write. Now next is 4th one. Define carbonate and non-carbonate hardness of water. Students, what is carbonate hardness? Hello. Temporary hardness. You have to write temporary hardness only. Okay. So non-carbonate hardness means?
Permanent
hardness. Okay, you have to write what is temporary hardness, you have to write what is permanent hardness, you have to write, and write the various disadvantages of hard water for domestic and industrial purpose. Already you know what are the defects are there, what are the effects are there for domestic purpose and industrial purpose, that you write. Okay, now this is 4th one. There is 5th one. 4 questions are there. Where is 5th one? Started 10th. So this I will check. Okay, na? In the afternoon class we will discuss. We'll complete this part B, part C in the afternoon class. Okay. So shall we stop the class? Hello.
Yes, sir.
Yes, ma'am.
Okay. So remaining questions will complete in the afternoon class. Okay.
Okay.
Okay, ma'am.